All right, Mr. Taylor, back with you with the second part for our real number property. And let's take up with problem number 7. Again, notes, guys, notes, and try your level best to go through and critique what I'm saying and understand what I am talking about as it relates to these particular properties. I thought that it will do us better justice if we looked at them from a problem situation than so from a definition situation. So anyway, let's get back to number 7. Laura correctly used a property of real numbers to calculate the exact value of the product shown below. So in plain words, she multiplied 840 times 998. So which of the following demonstrates a property that she could have used? So what they're telling us is Laura just literally said, okay, let me take 998 and multiply it by 840, putting that 0 to the side and doing our work. Well, according to what we see here, if we multiply 838 times 1,000, just making sure that we getting what she's actually trying to do. So let's see, 838 times 1,000, that's going to give us roughly 838,000. Well, let's go and look and see what we will get if we multiply 840 times 998, and that's going to give us 838,320. So as you can see, that's a few dollars less. B, she multiplied 838 times 1,000 and then added 2. That would give her $838,002 compared to $838,320. So neither one of these make sense. But if we take a look at C says if we multiply 840 times 1,000, let me show you how simple that is. So you have 840 times 1, 2, 3. Remember I was telling you about putting those zeros because they're not going to mean anything. So, and then she doubled 840, which is going to give her 0, 8, and 16. Well, actually, we're going to be subtracting. And if we go through this subtraction, it's going to give us 838,000. 838,320. Which is what we got from our answer here. So these two match. So that's the way that we could have did it, and let's just call it number sense. Okay, let's go and take a look at number 8. Which of the following statements describe how to use the inverse operation to solve? And I think I remember telling one day, I think a student asked me, well, why is it that we have to do that? Why can't we just, if we know the answer in our head? Then if they're asking you for the answer that's in your head, that's a good choice. But in this situation, they said, which of the following statement describe how to use the inverse operation to solve the equation? C plus 6 equals 16. Notice they didn't say anything about 0 pairs. Now, if you understand that concept and you want to use that, fine. Notice they didn't say flip, change, keep. They said the inverse operation. So they're using good 8th grade mathematical terms, and they expect for you to know these terms to solve the equation. So first thing, and it says, how would we solve it? So we know it's just a one-step equation, so we're going to subtract 6 from both sides. Okay, so that's going to give us C is equal to 10. So just going through that, A say multiply, but why? Okay, B says subtract 6 from both sides of the equation because subtracted, yes, right there. So of course that's our correct answer. And then that it explains using the subtraction property to solve this problem where 6 is being added to C. Number 9. Number 9 says Ted uses the expression 10 plus C plus 2C to show the total number of ice cream cones he sold in one day. So they're telling us that he used community property. So community property says we can switch these things around and still get the right answer. So here we're looking at 10 plus C plus 2C, and they tell us that A says 2C plus C plus 10. B tells us 2 times. Oh, no. We'll put a little question mark here. C tells us 2 times C. Oh my. 2 times C plus 5 plus 2C. No, that's not it. And D says 4C. I'm just wondering where the 4 come from. Oh, okay, well, that's not it. So we go back to A because it was a good fit. So we can take the question mark off. We literally can, because in plain words, what we've done is we look at 10 and C, and they just simply traded places. Okay, 2C plus C. Oh, here's what they did. 2C plus C plus 10. Let's switch them around. Okay, move the property. Number 10, and the very last one. So this is real nice and sweet. Which of these equations shows the associated property? Associate property of multiplication. So associate property says you got to have three. Definitely got to have three numbers. Three numbers being multiplied, and what we do with these three numbers is we take a look and reorder what these numbers say. Right off the bat, A times B times C is equal to A. So we take A out, trade places with C, which is B times C. That looks like a good answer to me. Okay? So again, please go back through. Make sure you take notes on these so you can understand these particular properties as we go forward. All right.